Hi everyone! So for today, we're going to learn about special numbers called Pythagorean triple. Those are three sides that fit perfectly into a right triangle, and we will also able to see how to differentiate and how to know if it's a primitive or non-primitive Pythagorean triples. Now let's get started. So here's our learning objectives. At the end of the lesson, the student should be able to first learn what Pythagorean triples are and how to know of how to check if the three numbers follow the rule a squared plus b squared is equal to c squared. Second, understand the difference between primitive and non-primitive Pythagorean triples. Last, be able to look at a set of three numbers and decide if they form a primitive or non-primitive Pythagorean triples. So what does a Pythagorean triple mean? It is a three number called a, b, and c that follows the rule a squared plus b squared is equal to c squared. That means if you square a and b and add them, then you get the same as the c squared. Now let's have an example of Pythagorean triples. So we have numbers 3, 4, and 5. So following the rule a squared plus b squared is equal c squared, we'll square the three numbers 3, 4, and 5. So we'll have 3 squared plus 4 squared is equal to 9 plus 16, and add them, you'll get 25. And our 5 squared is 25. So it is a Pythagorean triple. Let's add another example. We have 5, 12, and 13. So we'll follow the rule again. 5 squared plus 12 squared is equal to 13 squared. So we have 5 squared plus 12 squared, we'll have 25 plus 144, and we'll add them, we'll get 169 is equal to our 13 squared, which is 169 also. So with that numbers, so 5, 12, and 13 is an example also of Pythagorean triples. So what does a primitive Pythagorean triple means? It means that the three numbers have no common factor other than 1. Means you can divide all these three numbers with the same number and still get a whole number.
How to know if it's a primitive triple? Let's now have 3, 4, and 5. So let's follow the rule. 3 squared plus 4 squared is equal 9 plus 16 equals 25, which is our 5 squared. It cannot be divided by 2 and cannot be divided by 3. So our GCD is 1. Therefore, our 3, 4, and 5 is a primitive Pythagorean triple. Next, we'll have 8, 15, 17. Let's follow the rule again. 8 squared plus 15 squared equals 64 plus 225 equals 289, which is our 17 squared. It cannot be divided by 2 and cannot be divided by 3. Our GCD of 8, 15, 17 is 1. Therefore, 8, 15, 17 is a primitive Pythagorean triple. You know if it's a primitive Pythagorean triple if the GCD is exactly 1, only 1.
Now let's talk about non-primitive Pythagorean triple. So what does it mean? These are the triples that where the three numbers share a larger or bigger common factor other than 1. Means you can divide all of them by such number, the same number, and still get another whole number.
To know if it's a non-primitive, let's have 6, 8, 10. Let's follow the rule of Pythagorean triple. 6 squared plus 8 squared is equal to 36, plus 64 equals 100, which is 10 squared. All numbers can be divided by 2. 6 divided by 2, 8 divided by 2, 10 divided by 3. So all those divided by the same number and still get another whole number, since the GCD is 2. Since they share a common factor 2, which is greater than 1, it's non-primitive triple. Let's have another example. 9, 12, and 15. Let's follow the rule. 9 squared plus 12 squared equals 81 plus 144 equals 225, which is 15 squared. All of the numbers can be divided by 3. 9 divided by 3, 12 divided by 3, and 15 divided by 3. All is the same. All three number divided by the same number, and you get another whole number. Our GCD is 3. Since they share a common factor 3, which is greater than 1, it is a non-primitive triple. By the way, if you know, you can have the GCD using prime factorization. It's simple as that to find the GCD.
How to tell if a triple is a primitive or non-primitive? Here's how you check. First, see if the numbers follow the rule a squared plus b squared is equal c squared. If yes, then move on. Second, find the GCD of the three numbers. And lastly, if the GCD is 1, the triple is primitive. If the GCD is greater than 1, it's a non-primitive triple. Now let's have practice examples. Let's have 7, 24, and 25. Is it a primitive triple or not? First, let's check by following the rule of Pythagorean triple. We will have 7 squared plus 24 squared is equal 49 plus 576 is equal to 625, which is our 25 squared. So that is a Pythagorean triple. Now, next is to find the GCD. So the GCD of 7, 24, and 25 is 1. So it is a primitive triple. Let's have another example like this number 2, 12, 35, and 37. So at first, we have to follow the rule again to satisfy its equation a squared plus b squared is equal c squared. So 12 squared plus 35 squared is equal to 37 squared. So that will be 144 plus 1225 is equal 1369. That's a Pythagorean triple, since 144 plus 1225 is equal to 1369. The second is GCD. So our GCD is 1, since the three of them can only be divided by 1. So 12, 35, and 37 is an example of it is a primitive triple. And number 3, 15, 36, and 39. First, you follow the rule again. 15 squared plus 35 squared is equal 39 squared. That would be 225 plus 1296 is equal 1521. So 225 plus 1296 is 1521. So that is equal to 39 squared, and that is a Pythagorean triples. Second is you find the GCD, and the GCD is 3. So 15, 36, and 39 is an example of non-primitive triples. Let's have more example for you to easily identify what is primitive and non-primitive triples. First, we have 13, 84, and 85. First, we have to follow again to the rule to satisfy the equation 8 squared plus b squared is equal c squared. That would be 13 squared plus 84 squared equals 85 squared. That is 169 plus 7056, and 85 squared is 7225. So since they are equal, it's a Pythagorean triple. Second, we find their GCD, and the GCD is 1. So 13, 84, and 85 is a primitive triple, since they have GCD that is only 1. 5 is 16. Let's have
another one again, 16, 30, 34. Follow the rule again. 16 squared plus 30 squared is equal 34 squared, and that will be 256 plus 900, and our 34 squared is 1156. Since they're equal again, it's a Pythagorean triples. And second, we're going to find their GCD, and since their GCD is 2, that is non-primitive. Since the three numbers 16, 30, and 34 can be divided with 2, and that is greater than 1. So that is a non-primitive triple.
So to sum up the lesson for today, the Pythagorean triples follow the rule a squared plus b squared is equal c squared, while the primitive Pythagorean triples has no other factor other than 1, while the non-primitive Pythagorean triple share a bigger factor or greater than 1.
Any questions? If none, I hope you learned something about this video, and before that, I will leave a few sets of triples for you to identify if you really understand what is primitive or non-primitive. That's all. Thank you.